Folks, hello and welcome to week 6. We are back using Desmos for our discussion post this week, and I thought I would just give you a quick introduction to this problem and show you some tools and hints on how to walk through this based on the statement of the problem in the course. So I've got my basic function here that I list up here in the first window, and f of x is x to the fourth over x to the fourth plus 1. And I'm only going to use a domain of x greater than or equal to 0. And the first thing that we wanted to do this week is just give this function some sort of scenario so that we can look at a couple of points on the graph using the first derivative and make sense of that practically. So what I have done here, I'm just going to say this function represents, let's see, cost of production to build some number of homes. And this function, models this maybe for 2, maybe 3 homes, but this is, again, just an idea of how we would use this or how we would use the base graph and the first derivative to make sense of this practically. Before I get into this, let me just show you how I've laid out some of these labels. So if you, let's see, if you go down to Windows 3, 4, and 5, when you list this ordered pair, so what I've got here is 1.5 and minus 0.25, and that's this point here on the graph. And I've put this label number of homes built. So that's just to represent what's going on the x-axis. And then on the y-axis, same idea. Looks like I went about 0.1 and then 1.5 based on the location of the graph. One of the neat things I found in Desmos to maybe if you want to do or put this in a little different position, if you go over here and just hold your cursor down, and as long as you have the label option on, if you look at this measure of radians, what this is, so at 0 radians, this tag is flat. But if I go in here and I put pi over 2, it puts it vertical. And then you can, based on the dot, you can move this around a little bit here. So maybe that's a little more appropriate here given that it's on the vertical axis. So just one of those neat things that you can do to kind of clean up Desmos a little bit and make these graphs really presentable. And then the final is the first derivative. Note that I just put this little notation in here, the kind of the is less than symbol, then 3 dashes, and then first derivative. So this is pointing at the first derivative. And again, based on the function, then I graph the derivative. So g of x is the derivative of f of x. And then again, if you hold your cursor down, you can, if you just want to distinguish this, you can do it however with either the dash or the dotted line. So I think the dotted line helps us out here. So just a couple of things here that we're going to look for in the discussion post this week. Let me just make sure it's clear here. Obviously, what we're looking for in the base graph, what we want us to do is we want the derivative to tell us about some neat points. And remember, when we talk about the first derivative, really only think of this first derivative in terms of a numerical value. So the rate of change of the base function at any point x is just simply going to be described by the functional value of the first derivative. So don't get too excited about the slope here. We're just really interested in the ordered pairs and, again, the rate of change. So a couple points where I'm going to get real interested here. Obviously, where I have a peak here, I want to make sure I understand what's going on there. And then as I look at the value of the derivative, looks like the value of derivative is getting really, really close to 0. And what's that telling me about the scenario that I have presented here? So let's say that the contract has been written and we're getting ready to go out and do the site work on these first 3 homes. And so what do I notice? Well, I'm looking at my cost. My cost is, as I start getting close to finishing up that first house and maybe some of the site work on the other homes, looks like I'm starting slow and then I'm getting to see this increase and that rate of change in the cost is being expressed here in the first derivative. Now, if you think about a house example, obviously you've got a lot of perhaps equipment coming on site to do site work. You're doing foundations, you're doing structures, and all that sort of stuff. So you would expect that cost up front to be, not so much a sunk cost, but there's a lot of cost up front. And then there comes a point where I see a peak in the first derivative. And so what is this point really telling me here? So where the value of the first derivative is greatest here is the greatest instantaneous rate of change in cost for the scenario. So right about just before I'm finishing up that first house, and again, maybe I'm doing some foundations and I'm doing some structures on the others, but right about here is my greatest increase in cost in the project. And again, that probably aligned with some finishing up some structure or finishing up some site work and some structures. What do I notice from that point? Well, first of all, we want to notice the value of the derivative is still greater than zero. So obviously we're still accumulating cost here. But what's happening? Well, my rate of cost is, while it's increasing at a decreasing rate, which is explained by the first derivative. And then as I get up towards, finishing up that second house, what do I notice here? Well, things are beginning to taper off, which is very nicely explained by the fact that the value of the derivative seems to be getting really close to zero as I get to these, towards the end of or in between the second and third home. So down in this portion, what's being explained here is that while the rate of change is still positive, it is getting really, really close to zero, which is a good thing, meaning my costs are starting to level out and I should be getting close to the end of the project. Again, if I was just going to build 3 homes, and again, maybe doing some of these things in parallel, again, the site work and the foundations and the structures, this would be a reasonable profile. Obviously, going from the third to fourth house, we wouldn't say that we're not incurring costs. That's absolutely not the case. But again, just to use this particular function in a scenario out to, again, maybe 3 homes, this makes good sense. So what we're going to encounter this week is, depending on the function, everybody's going to have a derivative that looks a little bit different. So, I would expect everybody to have at least 2 points or two points of interaction here on this first derivative, where you're going to want to explain what is this telling you in terms of the practical nature of your scenario. And just one more time for me here, again, what's going on here at the peak? What am I understanding here practically? And that is my greatest instantaneous cost increase right about here. And again, whatever that is, maybe, I'm writing a check that week for, the guys who are charging me for all the equipment they brought on the site to do my site work, and maybe all the guys that, poured and finished my concrete that week. That's probably my greatest cost. And again, what we're seeing here is, cost increasing at an increasing rate, and then cost still increasing, but increasing at a decreasing rate. And then the feature down here where we're getting towards the end of the project, we're winding things up. So those would be actually, I think I would say that there's 3 reasonable features here that I would want to correlate with the scenario. So I hope that's helpful. Again, some tricks here to make this graph look really nice, and then use it to explain your scenario. I hope that's helpful. But as always, if you need any help with this, please drop me a note, and I'll be happy to talk through it with you. Take care and have a great week.